In this video, I will be explaining trig integrals substitutions with tangent and secant. And the most important part of this to know is the formula 1 plus tangent squared theta equals secant squared theta. And the main point of substituting tangent and secant is so that you can integrate certain functions that you otherwise would not be able to integrate. And the hardest part of this is to know which either tangent or secant that you will substitute for x. And you have to look for patterns. So if it's a number plus the variable squared, then we're going to let the variable equal a tangent theta, so that when it reduces, you're going to be able to substitute in secant squared. And that's really easy for fractions when it's under a fraction, because it's really easy to take the square root of one variable, like secant squared, then a number plus a variable squared. And if it's a variable squared minus a number, then we're going to let that variable equal a secant of the variable. And a is just a constant in the specific problem. Whenever we solve these problems with trig integrals, you always have to find, say for instance, x, and then the a tangent of theta, but then you also have to find the derivative, the dx, and substitute that back in. So now let's try an example problem so we can see how to apply it. And so we have the integral of dx over the square root of x squared minus 6x plus 13. Now this one we have to change it a bit so that we can have it in the form of a variable squared plus a squared. And what we're going to do for this one is we're going to complete the square. And to do that, we're going to take x squared minus 6x and then move that to the side, and then plus 13. And to complete the square, we have to add 9 to the left side and subtract 9 to the right, so that you're adding 0, and it will make it, and it'll be equal. And so then we're going to get x minus 3 squared plus 4. And put that back into the equation, you get the integral of dx over square root of x minus 3 squared plus 4. Now, we see we have the form a squared and then a variable squared, and so we're going to say a squared equals 4, so a equals 2. And then we're going to let x minus 3 equal 2, because the a is going to be 2 tangent of theta. And you always want to find the derivative, the dx, because we need to substitute that back into the integral. And the dx is going to be 2 secant squared of theta, because you remember that the derivative of tangent of theta is secant squared theta. Now when we plug that all back into our equation, we have the integral of 2 secant squared theta d theta over the square root of 4 tangent squared theta plus 4. Now we have since we have tangent squared theta plus a number, we can make that from our equation 1 plus tangent squared equals secant squared. We can first factor out the 4, and then if you take the square root of that, you're going to have a 2. And then tangent squared theta plus 1 equals secant squared theta, as we can see in the next one. And we have, now we're going to have 2 secant squared theta d theta all over 2 square root of secant squared theta. Now the 2's will cancel out, and if you take the square root of secant squared theta, you get secant theta in the denominator. And so now our problem looks like the integral of secant squared theta over secant theta d theta. And we reduce that, we get the integral of secant theta d theta. Now the integral of secant theta is the natural log of secant theta plus tangent of theta plus c. And you're going to have to memorize the formula for the antiderivative of secant of theta, or you can derive it, but this is faster. And now we're going to have to substitute back in for theta, because remember our problem was originally in terms of x's, not theta. So we're going to have to make a triangle. So since we know that since we let x minus 3 equal 2 tangent of theta, then we can say that tangent of theta equals x minus 3 over 2. And so theta equals tan inverse of x minus 3 over 2. So if we make our triangle, then we have the opposite from the angle of theta is x minus 3 over 2. And so that means that using the Pythagorean theorem, the hypotenuse is the square root of x minus 3 squared plus 4. Now, knowing these terms on our triangle, we can solve for the secant of theta and the tangent of theta. So then our answer is going to be natural log of the square root of x minus 3 squared plus 4 over 2, because that's the secant of theta, hypotenuse over adjacent, and then tangent is, as we know, x minus 3 over 2. And you always want to add plus c, because that is your constant. Now, if you'd like more help on this problem, on this topic, visit the review worksheet to see extra problems and more techniques and strategies to solving these integral substitutions.